In the last video, we answered the following question. How do we take a data-driven approach to building items in our game? And we discussed how people typically model items in their game. They'll create an item class, they'll extend it into a few different types of classes, maybe weapon, armor, consumable. But we discussed a different way to model this. We said, what if instead of going the typical object-oriented approach, we create game entities? And these game entities contain components that help shape what that item actually is. So to recap, we've added a few components here. This is a stack of gold, and we can reuse some of the existing components for that stack of gold for something like this, which is a sword with flames. And we're going to take the same concept now and apply it to our player entity. So today's video is going to be focused around how do we build the player? How do we model the inventory component of the player? And what are the data structures that go into building that? So let's start off by drawing a diagram here. And we'll add some item slots. You get the idea. And a couple of items. And the first thing we're going to do is break the problem into two parts. The first part is we need to know the state of each item slot, including the index and whether that item slot contains an item. The second statement is we need to know overall which items actually exist in our inventory. And if we draw a box around this, these two statements really become the core of what our inventory component is. And if we apply the same approach that we did with the items, we now know that our player can also be a game entity with an inventory component that's attached. And so we can take a data-driven approach to define our inventory component and how the items interact with it. And so the next thing that we're going to do is jump back over into our project and take a look at what this looks like in the actual code and how we can leverage some of the existing functionality we've already added. So back in our project here, let's go to our ECS folder and we're going to create a new file. So this will be inventory.ts. And then we'll take a look at the way we've modeled the inventory component. And so if you think back to the two problem statements, we wanted to track all of the state of all of the inventory slots in our window. We wanted to track all the items that exist in our inventory. And so you can see that referenced here by the properties we've defined on this component. We still need to define what the actual data structure of the item slot is. So let's do that now. Let's create a data structure for the item slot. And for the time being, we're just going to reuse the same file. So let's paste the item slot in here. And the first thing you should notice is we're tracking two different properties. The first property is the item, which is really just the item ID. So it's a way to hold a reference to the item without actually holding a reference to the entity itself. So we're working with the ID of the item here. The second thing we're tracking is the slot index, which we'll use to quickly find where an item slot is positioned within the inventory window. And then we've added three different helper methods that just make it easier to work with the item slot. So has item, super easy, just a quick check to see if the slot currently contains an item or not. Add item will go and replace the current item with a new item. And if you don't check if the slot has an item first, we're actually going to throw an error because that's bad. You should check if the slot has an item first. The third one removes the item and then returns the removed item ID. So that's really helpful once we get into the actual logic of moving items around in our inventory window. And so bringing in the item slot here makes our inventory component really happy. No more squiggly lines. But there's still two things that we need to add to our inventory component. Now, I will preface this first by saying there is a sort of a philosophical thing with doing entity component based design where you shouldn't really be including much logic within your components. They should primarily be just data. However, I do think there are some exceptions to that rule, and I do think it's okay to include helper methods that don't really add gameplay logic to your components. Like that's the main thing you want to avoid is adding gameplay logic to your components. So the first thing we're going to add here is a helper method to return the first available slot. So as the name would suggest, it loops through all of the slots and returns the first one that does not have an item. And then the other thing we need to add is a dependency on the way Ecsy works. And I'll briefly explain this for you guys. Whenever an inventory component is added to an entity, it's going to call this copy function. And so the main reason we need to include this is because we want to transform our array of item slots into a new array of item slots. That way we don't have any state bleed from one component to another. And so copy is one of the lifecycle methods that exist on a component within the Ecsy framework. If you're interested in learning more about Ecsy, I can share a link to their documentation in the description of this video as well. Now the time has come to create our player entity. So let's go into our prefabs folder, and I've already created a player.ts file. Here is our player preset. This is the definition of the player that will ultimately get mapped into the components that will make up the player entity. And so right off the bat, you should notice we have an inventory component with slots and items. And so it's a one-to-one match with the component that we just created. If we take a look at the slots, you should also notice there's two properties. There's slot index and there's item. And this also matches with the shape of the data we defined within the item slot data structure. And for fun, we've added a descriptor component to this player as well. Maybe let's add a more fun name. How about, I don't know, hey, this is dev by dusk. Secondly, we've created a function that will grab the player preset, create a new entity ID, and then return an initialized entity with all of those components attached to the player. Okay, so here's the current state of our inventory window that we built in the first video. So we're going to open up the dev tools. We're going to put a breakpoint on the getPlayer function, and then we're going to do a refresh. So let's take a look at the actual game entity getting created here. So I see that I have two components on my player entity. I have my descriptor, which has successfully captured the name that we added to the descriptor component in our player preset. I have the entity ID component, which was added dynamically whenever we initialized the entity. But we're missing our inventory component. So we forgot to add it to the code that actually registers the components with Ecsy. So let's go back and do that really quickly. So back in the project, open your components.ts file. And here we need to import inventory. Let's do that. Import inventory from inventory. And then we're going to add it to all three locations where we're exporting the inventory class, the inventory component. As well as here, type of inventory, and save. Now, if we go back to our inventory window in the DevTools, we should see that the inventory component is getting added to our game entity. And let's refresh. And we'll step over that and take a look. There we go. We've got three components now. So we can see that the inventory component was registered on our game entity. And if we look at the slots, it should be 25, as we see here. And each of the slot indices got added appropriately. So now that we've got our player entity with the inventory component configured, we can move on to building out the functionality of the game logic that'll be responsible for working with this inventory component and modifying the state of the component. We're back in our project here. Let's go to the inventory folder, and we're going to create another subfolder here called state. Inside of the state folder, we're going to create inventory utilities. And this file is going to hold all of the gameplay logic responsible for modifying the state of the inventory component on the player. And then we'll define one more subfolder here called events. And inside of events, we're going to define the inventory event emitter. And this is going to be an event emitter responsible for letting the UI know when there's been state changes so that the UI can re-render. And currently, there's only two events that we care about right now: item added and item moved. So I've created an inventory event enum to hold these. Now let's create the actual event emitter. So I'm currently wrapping the existing phaser event emitter because why recreate something that already exists? Now, the reason I'm doing this is so that I can type the payload that I'm going to be sending out with our events. And so we've got to define the event map that's going to do that for us. So let me grab a couple of things here, import all of our references. But by itself, this does nothing. There's nothing listening to these events currently, and there's nothing publishing these events. So let's build out the logic now that's going to publish these events first. Let's go back to our inventory utilities. And here we're going to export const inventory events equal new inventory event emitter. Now we've got an instance of our inventory event emitter that we'll use for publishing and for subscribing to events. Now we're going to add the scaffolding for a couple of functions here. So add to inventory. Let's import references and move item to slot. So add to inventory is going to take in two parameters, the actor and the item. The actor is the player entity that will be receiving the item. So it has the inventory component that we need to modify the state of. And the item is, again, the actual item that will be added to the inventory. So to do some pseudocode here, we know we'll need to first grab the inventory component from the player. Next, we need to find the first available slot in the inventory. We need to add the item to the slot, and then we need to publish that an item was added to our inventory. Now let's grab the inventory component from the player. To do that, we'll grab a property called inventory mutable from our actor. And the reason we have to get the mutable version of the component is because anytime you make changes to the state of a component, you've got to let Ecsy know that you're doing that because it does some change tracking under the hood. Now, we're not going to take advantage of the change tracking for our purposes in this video, but it'll yell at us if we try and mutate the state of properties on a component without first grabbing the mutable version. So now let's go into our game entity here and define inventory mutable. So again, this game entity is a wrapper around the base entity that Ecsy provides just to add some easy accessors for many of the components. And internally, it just wraps the API of Ecsy. So currently, we don't have any versions of the inventory component on here. So let's go ahead and add that now. We can just copy one of these existing ones, change this to inventory mutable. This returns an inventory component. Inventory. We'll change this to get mutable. Make sure we populate all of the different places so we can type it correctly, and then we'll change this to inventory. Now we should be able to go back to our inventory utilities and see that the compiler is happy now. Step number 2, let's find the first available slot in the inventory. Luckily, we already created a function for doing this, so this should be pretty easy. Const first available slot equals mutable inventory component dot first available slot. So it's worth pointing out that we're not doing any validation to check that the inventory is not full before adding an item. So you'd probably want to do that. For this video, we're just going to assume that there's an open slot to add the item to. So the next thing we want to do is actually add this item to the available slot. So we can do that by saying first available slot that add item. And we're going to pass in item.entityID.value. Because our item slots care about the IDs of the items, not the actual item entity itself. So whenever a new item is added to our inventory, we're going to want to add a picked up component. And the reason we want to do this is so that we can track the slot index that the item is currently in. So the last state management piece that we need to complete here is updating the collection of items that exists on our inventory component. So let's do that. We'll do mutable inventory component.items.push. And we're going to push the ID of the item. So item.entityID.value. And now the final piece of the puzzle here is to just publish that the item was added. So we can use inventory events.emit. And we're going to pass in the name of the event. So inventory event dot item added. And you see we get our type for the payload here, which is just the game entity. So we know all we need to do is publish the actual item entity itself. Now let's chat about our other function here, move item to slot. So this one also accepts two parameters, an item ID and the target slot index. The target slot index will come into play more so when we build the drag and drop functionality. Because when you think about drag and drop, you're ultimately trying to specify which specific slot you're dropping an item in. And in that case, you would provide the actual slot index of the landing slot during the drag and drop process. So we'll go ahead and include the target slot index now, but we're really not going to make use of it yet. Let's do some pseudocode here. the first thing we want to do is look up the item based off the item ID. So look up and grab item entity from item ID. Then we need to grab the current slot that the item resides in. So grab current slot of item. And then we'll add the item to the new slot. And then we'll publish an item moved event. So this will be the general flow. So to grab and look up the item, we're going to call world.entitymanager.getEntity by name. And I can see that entity manager is not recognized on the world type. So let's fix that. And the way we can fix that is let's go into our source folder and we're going to create a new folder called @types/Ecsy. And we've got to provide an extended type definition file for the world.ts class. So I'm going to create a new file in here, world.d.ts. And then I'll share with you guys what I have for this file. I'm not going to go too in depth about why this is needed, other than the fact that the type definition file for this library isn't super great. So I've made it a little bit easier to use by adding my own module for Ecsy. And then if we go back to our inventory utilities, everything's happy now. So we grab the item. Let's call this item entity just to be super clear on what the actual object is. The next thing we need to do is grab the current slot of the item. So to grab the current slot of the item, we need two things. We've already got the item entity, but we also need the player entity because we need to grab the inventory component off of the player. Now we're exporting a global const referencing the player entity value. Now it's not great to use global variables, but for a tutorial video, it makes things a little bit quicker. Ideally, you'd probably have some way to look up the player based off of the entity ID, and maybe we'll get there at some point. But for now, let's just paste in what we've got. Okay, so grabbing the current slot from the inventory is as simple as just iterating through all of the slots and finding the first slot that has the entity ID of the item that we're trying to move. And now our next step is to remove the item from the current slot. So that's easy. Const item ID, call this removed item ID equals current slot dot remove item. The next thing we want to do, find the target slot of the item. I mentioned we're not going to use the target slot index for now. So what this is just going to be then is the first available slot. Let's grab this. And then instead of searching for all the slots, we'll erase part of this and we'll say, instead of dot slots, we'll say first available slot. And we can call this target slot. Now, we need to add the item to the target slot. The target slot, that add item, we can use removed item ID. Technically, the removed item ID is the same as the item ID in this case. However, because we've said that the current slot can be undefined, this would be the case of you tried to add an item to your inventory that was not currently in a slot. So you'd want to add some validation around this. For the tutorial, I'm just going to say you can expect that the current slot will always exist. And then we'll add it to the target slot. So whenever you change the slot index, you also need to update the picked up component on the item entity. So let's do that now. Item entity.pickedup. And we don't have a mutable version of this yet, so we need to create that. Otherwise, Ecsy will yell at us for mutating the state without calling the mutable version of the component. So picked up, mutable. Let's go over into our game entity class, game entity. And we should have a reference to picked up somewhere in here. Okay, so we can just copy this. And we will do picked up mutable. And all we need to change is get mutable component, save the file, go back to inventory utilities. And now we can say picked up mutable dot slot index equals target slot dot slot index. And we'll need to change this to, let me see, what is it complaining about? Oh, because it thinks it could be undefined. Again, we are not going to worry about validation for this video. So let's tell the compiler that target slot will always be there. And then the last thing we need to do is publish an item moved event. So inventory events.emit, inventory event.item added, inventory event.item added. And we'll give it, let's see, not item added, sorry, item moved. So item moved. And we'll give it 2 properties here. So it needs the current slot index. So that's going to be current slot dot slot index. And we need to give it the item as well. That'll be item entity. And we need to specify that current slot is defined. Now, the reason we're publishing this event with the current slot index is because the UI has not yet updated its state. So in the UI, in the actual inventory grid in the UI, this item still exists in the current slot. So the general flow is the player will initiate some movement or some action on the inventory grid. That'll generate an event, which will then go and call our code to update the state of the inventory. The inventory will update its state internally, and then it'll publish an event that the UI is listening to. And the UI will go then and update its state and re-render everything. And so what we've defined today is just the state management piece of the internal state of the inventory component of the inventory window. In the next video, we're going to actually get into the interactivity with the inventory grid. So that's going to build up all of the functionality of the inventory grid slot through a compositional manner. But before we wrap up this video, let's go ahead and clean this code up a little bit because I don't like leaving all these comments around. It should be pretty self-explanatory what's going on here. I'll add a couple spaces for some white lines. But as I do that, I want to thank you all for watching. We're getting close to the end of this series. I think in the next video, we should be pretty close to the original demo that was shown in the first video. So I'll see you in the next one.